So first thing we're gonna do is we're gonna create a new Houdini project, and let's save this somewhere like under River Tutorial folder. I'm gonna call it River Tutorial, and then I'm gonna create a geometry node. I'm gonna call it River Tool. And then first thing, I want to have a simple curve that slides on the terrain. So we will need to create a height field and a curve. Later on, I will replace this with Unreal Spline as an input, but for now, while we are creating the tool, we can use this. So I'm gonna change the size of the terrain, so it's very similar to what Unreal recommends. I'm gonna set the grid spacing to 1, and then I want to alter the height of the height field by adding some noise and changing the height so it bends towards a certain direction. So I'm gonna say height field wrangle, and I'm gonna say the height is equal minus position on the z-axis divided by the size, and then multiply it, let's say, by let's create a parameter here. I'm gonna call it bend intensity, and then I'm gonna multiply it by this parameter. Let's create the spare parameter here, so we have something. I'm gonna set it to 50, and after this one I'm gonna say plus position on the x-axis divided by the size and multiplied by the bend intensity. Now, as you can see, it gives us this. Right, so I'm gonna let it at 50, and then I'm gonna say height field noise. So I don't want it to be too much, or something like this is probably fine. Right, again, leave the element size like this. Okay. All right, this should be fine. I'm gonna set the 150. Okay. Then the next thing, we will draw a curve. So I'm gonna make sure to enable grid snapping and hit enter, and then let's click Control and enable the template here so we can see our height field. And I'm gonna just make sure the curve, I'm gonna draw some abstract curve like this. So it just goes here, let's say maybe here, and then somewhere here. Okay, so as you can see, our curve is very abstract. It doesn't follow the terrain, and it's very low res. So what I want to do is I want the tool to resample this curve to some high resolution curve, and then based on some input like the number of iterations, I wanted to take very small steps and towards the slope. Essentially I wanted to slide on the terrain. Okay, so to do that, first thing we need is the resample node. I'm gonna set this 2 for now, maybe just 4, right? Again, set the subdivision curve. Yeah, let's leave it straight edges for now, doesn't matter at this stage. And then what we're gonna do is I'm gonna create a Python script. So I want to create it as a new node, so you can reuse it in different projects if you want to. So I'm gonna say new asset. I will call this tutorial river tool, and the network, the definition gonna be in Python, network type geometry, save to library. I'm gonna call it tutorial river tool. I'm gonna say accept. Okay, it should be like this. And then I'm gonna say tutorial river tool. So gonna place it like this, and then let's say edit Python source code. So in my case, I did set up Houdini in a way it uses Visual Code as the default editor. Also, I linked Visual Code with the Houdini modules. So I'm gonna say import the Houdini module. It will help with identifying the function and everything. So first thing we need to do here is I'm gonna grab the inputs. So I'm gonna say input node equal node dot inputs, and curve, it will be the input 0, like this. Geometry, so here we grab the curve. We will not necessarily use this because the input node 0 is a read-only variable, so we will just probably use this directly. This will give us the curve with the permission to do some edits to it. But what we really need here is the volume from the second input, which is the height field. So I'm gonna say dot geometry, and the height field will be the primitive, the first primitive in this volume, because essentially there is for example, if I go to my terrain under geometry spreadsheet, there is the height primitive, which got the index 0, and then there is the mask primitive, index 1. So we need the primitive at index 0. So as you can see, for example, I can just say print height field, and let's add another input here. I'm gonna say the minimum input is 2 and maximum input is 2. Let's give it the height field, and as you can see, it prints the volume primitive 0, and comes from the height field nodes, which is a read-only variable here. So what we're gonna do now is I'm gonna say for every curve as an input, In our tutorial we are only dealing with one curve, and we are not dealing with things like intersections and stuff like this, but you can easily later implement those while using the knowledge you will acquire in this tutorial. So I'm gonna say for every curve in the curves input, in the first input, or for, let's say, for every primitive, we're gonna say grab the points of this curve or this primitive, and then for every point in points, gonna say let's grab its original position, and then we're gonna sample the height at this at the original position from the volume of the height field. So I'm gonna say sampled height equal height field dot sample original position. And if I just use this, let me show you the result of this. So I'm gonna say new position equal let's say the original position, the x, essentially the x and z will not change where this sampled height obviously is a flow, so we are only interested by the height. Okay, we want to snap the curve to the right height of the terrain. And here I'm gonna say sampled height, and this one original pose 2, and then I'm gonna say point set position to be new pose. And if I do that, let me just go to my node here. I'm gonna enable the template, and as you can see, the curve just snaps to the right height. So as you can see, it just snaps to the right height. Now that's a good step, right? But we're still missing the sliding thing, right? We really want it not only to snap, but to slide on the terrain based on some number of iterations. So the way we're gonna do the sliding thing is we're gonna sample the gradient of the volume at the same position. Essentially, the gradient is the rate, the gradient essentially will give us back the direction in which the rate of change of height is much higher, right? So let's do this. Okay, so I'm gonna say gradient direction is the height field gradient at the original position. All right, so this is the direction. Okay, and I'm gonna say gradient offset, right? So this is a direction, and I'm gonna multiply this direction by some kind of scalar, right, to control essentially how long the step is, right? So we want to really take very, very small steps while sliding on the volume around the terrain, so we don't do some overstepping. Essentially, overstepping is like you take long steps, which might cause in situations where you really never reach the lowest point possible in the terrain, or you might even skip it. So I'm gonna the gradient offset gonna be the gradient direction multiplied by some parameter. We're gonna call it step multiply, right? Let's leave it like 0.5 for now. I'm gonna replace this in a bit. Now the new position will be the original position plus gradient offset 0, and then this one gradient offset 1, then this one plus gradient offset 2. Right now it's not very obvious because we are taking very small step, but if I change this like to 5 and 10, as you can see, like it is sliding on the terrain. Okay, so but currently, let me show you. Let's pick an area where the slope is quite high. Right, so I'm gonna change this to 0.5, and I'm gonna change this to 5, and you will notice that it's taken a step towards the wrong direction, right? But let's keep it like this for now. So it might be not very obvious for you now, but let's just run this in a for loop now. Okay, so I'm gonna say repeat. I'm gonna say for loop. Under the for loop, you're gonna place the slide script, and as you can see, I'm gonna like change the number of iterations, and as you can see here, it is sliding, but it's not necessarily sliding in the right direction. As you can see here, for example, it's actually going up, like it's going against gravity instead pulling towards gravity, right? So all we have to do is just invert the direction of the gradient here. So I'm going to say minus gradient direction, right? And now, as you can see, it just slides down instead. So this is what we need. You see, this is what we need. Okay. Now, one issue you might encounter is like every time we take a step, we might really need to resample the curve, right? So we keep equal distance between all the curve points. So all you have to do is grab this resample node and just apply it somewhere here just after the script. And as you can see the result, right? Now we don't get this weird breakup. Okay, now all you have to do is I'm gonna expose a parameter, all right? And expose a parameter here for the step multiplier. I'm gonna say parameters. It will be of type float, and we will call it step multiplier. Right, it's called step multiplier. And somewhere here I'm gonna say step multiplier equal Houdini, or let's say equal node dot param step multiplier, and then evaluate. And let's just place this here. Okay, now you have this. You can see what's happening. So just one rule I always follow when dealing with things like these. It's always good to just keep this step multiplier quite low. But while you're developing the tool, you can just leave it slightly little bit. You can just leave the number of iterations a little bit low, right? So so you don't need to wait too many iterations, so you can continue developing your tool, right? So I'm gonna set this to 64 iteration, and gonna set the number of steps like 0.75, something like this. So this is what we have now, right? You can increase the number of steps, right? Something like this. And then just at the very end, once we're done, you can run this one last time. So it samples the terrain height again and set the while setting the step multiplier to almost 0 or 0. And as you can see the result. So what we did here, you can do it in using a Houdini Vex, or you can use other methods. But that's, I guess, the beauty of Houdini here. Like, there is always many ways to achieve any particular task, and I found it much more easier for game developers, at least, um, to write their tools in a language like Python, because there isn't really much stuff here going on. It's almost like it's plain English, right? Like anyone can just read these lines and understand what's going on. Okay, so with in place, the next part will be we need to deal with let's say with creating the river mesh itself, and deforming the terrain, and we need to always like make sure the river always flows down and never up, like for example in this case it goes down and then up again. That doesn't make sense. Like the height of any particular point should not be higher than the height of its previous point, right? We can of course allow certain threshold, right? So we leave role for we leave room for some flexibility. So level designers, while placing this tool, can be easy for them to deal with this. Okay.